lesson, we will look at section 41, piecewise function modeling, and this is the first day of a two-part lesson. The use of the calculator is required for this section. So for number one, parking rates at Millennium Park in Chicago as of October 2017 are as follows. It's $14 between 0 and 3 hours, $18 for more than 3 and up to 8 hours, and $22 for more than 8 and up to 24 hours. If T represents the number of hours parked and F of T represents the total cost, create a piecewise function which represents the above rates. As we've worked with piecewise functions previously, we would have a column of expressions and we would have a column of inequalities. And that's how these are going to look as well. Now, with the first condition is saying that it's $14. Now, not $14 per hour, just $14 for between 0 and 3. So the way we would express this is just 14, and then for the inequality, since T is the number of hours parked, it's between 0, so more than 0, and less than or equal to 3. The next condition is saying that it's $18 for more than 3 but up to 8 hours, and that statement is going to look like this. It's just the flat rate of 18, and again expressing that it is more than 3 and up to 8 hours. And then for our last piece, $22 for more than 8 and up to 24 hours would look like this. So that is going to be the setup for this particular problem. Now for number two, a paperback sells for $12. The author is paid royalties of 10% on the first 10,000 copies sold and 15% on any additional copies. Let X represent the number of copies sold and let R of X represent the total royalties. For part A, again, we're going to create that piecewise function, just like we did in the last problem. Now here, there's really only two situations. Since we're looking at one condition being up to 10,000 copies sold and then the other one being beyond 10,000, that's what's going to give us our two pieces. So the first one, we want to realize that since the paperback sells for $12, the author is going to receive royalties, which is their percent that they're going to make off of that. They don't just make the $12, they only are going to make a percent of that. So we need to figure out what that amounts to. So if we take that $12 and multiply it by 0.10, we're going to get that the author is receiving $1.20 per book for the first 10,000 copies sold. So now we'll go ahead and put that into our function. And that is going to say 1.2x. Now notice this time we did have to include a variable here. Again, it's because that's $1.20 per book. So it depends on, is there one book that's being sold versus is there 10,000 being sold? That's going to make a big difference in how much money that the author is making here. Now, the next part of this that we talk about is if they sell exactly 10,000 books, this author would receive exactly $12,000. Again, I would take that 10,000 and plug it in for X. Multiplying those together would give me that $12,000. So when we move on to the next statement, we have to realize that the author is going to earn $12,000 plus an additional 15% on that $12. So at this point, we want to figure out what is their new rate. So if you take that 15%, so 0.15, and multiply it by 12, so beyond 10,000, the author is going to make $1.80 on each book. And so when we talk about this beyond 10,000, we need to express that algebraically. And so what we want to do is take our new number, which we'll call X, and subtract 10,000. So say if the author is selling 10,001 books, by plugging in that 10,001 for X, 10,001 minus 10,000 would just give us 1. So only one book should be making $1.80 per book. Or if we're selling, say, 20,000 books, then we would be doing 20,000 minus 10,000, and that 10,000 would be making that $1.80 per book. So the way that we're going to express this, again, is that 12,000, the amount that we would get by plugging in the 10,000 here, plus the new rate, which is $1.80, times that quantity that expresses beyond 10,000. And again, this is the condition when X would be greater than 10,000. Now part B, we're talking about if the author sells 12,000 books, how much will the author earn? So when we're deciding which one to plug it into, we know that this one down here is saying X is greater than 10,000. And since our amount is greater than 10,000, that's where we need to plug it in. So we'll go ahead and do that. And when we plug in 12,000 for X here, we end up getting $15,600. And so you want to kind of make sure that that seems logical. We know that 10,000 would earn the author $12,000, and we know we're earning a higher rate at this second amount. So if we're selling that extra 2,000, it does make sense that we would be around 15,600. For C, it says how many books have to be sold in order for the author to earn $9,000. Because these are the number of copies that are sold. So we want to consider the fact that in this situation, we know that by plugging in 10,000 here, it got us 12,000. So since $9,000 is less than that amount, it would have to fit into this portion of our problem. So we're going to go ahead and set 9,000 equal to 1.2x. And at this point, we can divide both sides by 1.2 and we get 7,500 bucks. For part D, how many books have to be sold in order for the author to earn $30,000? Well, again, if we think about the fact that the maximum amount that we can get in this situation is $12,000, we've got to be dealing with this expression right here. So from here, we'll go ahead and set that amount, $30,000, equal to this expression down here and solve from there. So the first thing I would do is subtract 12,000 over and then divide by 1.8. And then at that point, finally, we can go ahead and add over the 10,000 to get 20,000 bucks. In this next problem, during a 9-hour snowstorm, it snows at a rate of 1 inch per hour for the first 2 hours. And that's going to be condition number 1. Condition number 2, 2 inches per hour for the next 6 hours, and then 1 inch per hour for the final hour. So we're going to have 3 separate conditions here. So when we're going to set up this piecewise function here, the first condition again is saying it's snowing at a rate of 1 inch per hour for the first 2 hours. So I want you to take a minute to try to set this up on your own. You can pause the video, try to set up these 3 different statements. You'll have 3 expressions and 3 inequality statements on your own, and then play through the video to see if you're getting the correct answer. So for this first part, I'm just going to say T. T is the number of hours since the snowstorm began. And it's 1 inch per hour for the first 2 hours. So I could put 1 T here, but T is just fine. And then again, to express the first 2 hours, I've got to show that it's, more than 0, but less than or equal to 2. My next condition is saying that it's 2 inches per hour for the next 6 hours. So since our function is representing the total snowfall here, we do have to realize that 2 inches of snow has already fallen. So we have to take that 2 and account for that in our problem by taking 2 plus, and then our new rate is 2 per hour. But since that's after 2 hours, we need a way to express that after 2 hours, and the way that we're going to do that, similar to the last problem, is T minus 2. So this expression, again, should be 2 plus, and that 2 came from like our total amount from the first amount, and then plus, this is our new rate, and then times an expression. And now when we move on to our third piece, like one thing that we need to consider right away is if I plug 8 into this, the snowfall after 8 hours would have been 2 plus 2 times, this is 8 minus 2 right here, so 6. It's 2 plus 12, which is going to be 14. So 14 inches of snow have fallen so far. So then at this point, when we go to set this up, it's going to be 14 plus, and now we need an expression to represent it's 1 per hour after 8 hours. And again, that after 8 hours is going to show up as T minus 8. So when we plug this one in, that would be our last piece. And again, it's for the final hour. So that's hour 8 to hour 9. For part B, what was the total snowfall for the storm? Well, we're going to get that by plugging in our last number into its corresponding expression. So by plugging in 9 there, we end up getting 15 inches, and that would be the total amount of snowfall on the ground. Part C, if the storm began at 9 a.m., how much snow had fallen as of 3 p.m.? So if we're thinking of 0 as being 9 o'clock a.m., we want to think about the fact that 3 p.m. is 6 hours later. So if this is our initial point, 6 hours later would be plugging in a 6, and you've got to plug it into its corresponding expression. So when we do plug that in, it's 2 plus 2 times the quantity 6 minus 2. and that's going to give us 10 inches. For D, if the storm began at 9 a.m. and Jamie was able to clear the driveway of snow at 12 p.m., how much snow remains to be cleared after the storm? So again, we're saying that 9 a.m. would be this 0. So if 3 hours later at 12 p.m., the snow was cleared, so by plugging 3 into that second expression, that second piece, we end up getting 4 inches of snow had been fallen, and that was cleared by Jamie. And so since the total amount of snowfall was 15 inches, if we take away that 14 inches, that means that there'd be 11 inches left to be cleared. So moving on to number 4, when you have a job, a portion of the deductions in your paycheck is Social Security. As of October 2017, 6.2% of your paycheck goes to Social Security. However, no additional Social Security is deducted after $127,200 in earnings during any particular year. Let W represent your total wages in a year, and S of W represent the total deductions for Social Security. And we're creating this piecewise function again. So again, we want to think about how many different scenarios we have here. We really have 2. We have one that happens before and up to 127,200, and then we have a condition for after that. So when we talk about our first one, it's 6.2%, which we're going to treat as a decimal, 0.062, of your wages up to 127,200. So when I express that, it's 0.062 times W, because it depends on how much you're actually taking in, whether you have an income of $10,000 a year or if you have an income of $100,000 a year. That's going to determine how much money is coming out. So if you were to make exactly $127,200, by plugging that in for W there, that means you're paying $7,886.40 in Social Security deductions. So when we move on to the next piece, that's the flat rate that anyone beyond that is going to pay. So since it's no additional deduction, it doesn't matter if you make $128,000 or if you're in the millions. You're going to pay that flat rate of $7,886.40. So now that we've set up the function, try to do B again by stopping the video, try the problem, and then play it through for the answer. So if Marie has this part-time job that pays $200 per week, and assuming 52 weeks in a year, how much will Marie pay in Social Security deductions in a year? So if it's $200 per week, we would first of all have to multiply that by 52 weeks to figure out her total amount of money that she's making during a year, which is going to be $10,400. So at this point, since her earnings are definitely between 0 and 127,200, we'd be plugging that in here. So by plugging that in there, we've got 0.062 times her earnings, and that's going to give us $644.80 that she's paying. Now do the same thing for C. Go ahead and pause the video, try this problem, and see what you get. Now at $85,000, that's going to fit Ken into this first condition. So again, I'm going to be plugging it in for W here. So by multiplying those together, this person is paying $5,270 in Social Security deductions. So again, pause the video and try this problem and then play it through for the answer. So if this person is making $1.2 million each year, we can see that that wage value is definitely above the cutoff of $127,200. So this person would pay that flat rate of $7,886.40. For number 5, the height of the front of a camping tent can be modeled by the function that's given there, where x and f of x are measured in feet and the x-axis represents the ground. Rewrite f of x as a simplified piecewise function. So we know that with an absolute value function, we're going to have 4 different things to fill in, 2 expressions, and we're going to have 2 inequalities. Now I keep talking about with the inequalities, we're starting with these inequalities, and we get this by taking x minus 2.5 and setting that greater than or equal to 0. You can see the work for that here. And then I would have added the 2.5 over to get this top inequality. X is greater than or equal to 2.5. And then from there, we would have built this one, which is going to represent basically the other side of 2.5. This is x is less than 2.5. Now, as far as what we're getting here for our expressions, the work that supports these answers is up here. So we know that for setting up this first piece, we shouldn't be changing anything at all other than just making the absolute value signs turn into parentheses. And then for the bottom piece, we don't change anything other than what's inside the absolute value. Now, you could represent it the way that this is written here, where the negative is out in front of the parentheses. The way that I tend to do this in class is I would put the negative with the x and a positive with the 2.5. Either way, you're going to result in the same answer. If I was doing it like that, I would have a negative here and a positive here, and I wouldn't have any symbol at all right here. So either way, in this one, we're distributing in the negative 1.4 and then combining it with positive 3.5 to get this expression right here. And then over here, again, in this case, the way that this is represented, we'd be distributing that negative, also distributing the negative 1.4 and then combining with 3.5 to get our expression that we have here. Now for part B, we have the expression. So again, pause the video, try to see what you would get for this answer. Now at 2 feet, the way that this turns out, the process that we've been doing it, it kind of turns out a little different than what we're used to in some of our other sections. This is not going from left to right. So this is saying that x is greater than or equal to 2.5. So this would be like the right side of this function, and then this one is the left side of the function. So as long as we realize that 2 is smaller than 2.5, we would realize that we need to plug it in here. So if I do 1.4 times 2, we're going to get 2.8 feet. Try C. Now for this one, they're talking about the maximum height of the front of the tent. So we know that an absolute value graph is going to be V-shaped, and we also should know that because this has a negative lead coefficient, it is going to be a V shape, but it's going to point down. So the top of the tent is going to be the vertex. And our vertex here would be at positive 2.5 for our X value, and then positive 3.5 for our Y value. So because of that, 3.5 is going to be our answer. The other way that you could get that is by actually taking that x as 2.5 and plugging it in, and plugging it into that top piece where it's equivalent to, that would give you 3.5 feet. So either way that you did that would be fine. Go ahead and try part D. And for this one, when it says, why can't we find the height at 10 feet? Well, what you want to think about is 10 would be in this condition right here. 10 is bigger than or equal to 2.5. So I'd plug it into this piece right here. And what I'm going to get here is negative 7 feet. So what that means is underground as far as this one. So it makes no sense to find the height because it's not realistic. Being that it's below, that it would end up being below the ground, we would never try to find the height of that. Go ahead and try E. So what we're looking at for this one is if we're trying to establish the distance across, we need to know where the height is 0. Wherever the height is 0 is going to tell us about our endpoints. So the height value would be that f of x value. So if I take 0 and I set it equal to the first expression, subtract 7, divide by negative 1.4, and we're going to get 5. Taking that bottom expression, which this should be positive 1.4x, and setting that equal to 0 is going to give me 0. So then if one point is at 0 and one point's at 5, they are 5 units away from each other, and so that's why the width is going to be 5. And for our last problem, an air conditioning salesperson receives a base salary of $2,850 per month plus a commission. The commission is 2% of the sales up to and including $25,000 for the month, and 5% of the sales over $25,000 for the month. So again, as we're reading through this, we kind of want to notice that our two conditions are surrounding that $25,000. So that should help you figure out what your inequality is going to be. Then it says let x represent the amount of sales and let f of x represent the total salary. See if you can come up with this piecewise function. And so for this, again, if we know that our two conditions are going to surround this $25,000, one of the conditions is going to be when X is less than or equal to $25,000. And so since this person is going to make $28.50 plus commission, it's $28.50 plus. The commission is 2%, so we're going to think of that as 0.02 times whatever the sales are, and that's why we've got an X with that. Now from here, we would go ahead and plug that 25,000 in for X to find out how much this person is going to make if the sales are at $25,000. So when you plug that $25,000 in, you're going to get $3,350. So for our next condition, it's going to start with that $3,350 plus, and then our new rate is 5%, so we'll do 0.05. But again, because that's over the 25,000, we set that up as X minus 25,000. That way, if we're plugging in 25,001, we realize that we're only plugging in a 1 technically then here that's multiplying by that 0.05. So for part B, go ahead and pause the video and see if you can answer that question. So again, we have the setup here. One thing that we've got to realize with this one is that because X is representing the amount of sales, if the person's sales are $30,000, we're going to fit into this bottom condition. So we're going to go to this condition in green and plug in 30,000. Well, when we do 30,000 minus 25,000, we get 5,000. Typing all of this in is going to give us our final salary, and that's going to be $3,600. All right, for part C, using that same expression, this time the person is earning $6,000 per month. So it's not telling us the sale amount. This is the sale amount here. So what we would need to do is take that 6,000 and plug it in basically for f of x. But one thing to keep in mind when we're figuring out which expression to use here is that $25,000 in sales got us a total of $3,350 for the income. So our income is more than that, which tells us to use this bottom expression. And so we set 6,000 equal to that bottom expression, and then algebraically you're going to solve. So we'll subtract this. I would divide by the 0.05 and then finally add 25,000 over, and that's going to give us $78,000. So if the person was earning $6,000 per month, that means that they needed to sell $78,000 worth of materials. So at this point, you should be completing the practice set for the section 40 part 1, and please let me know if you have any questions.